In January 1941, Charles Sorensen stood under the bright California sun at Consolidated Aircraft San Diego facility, watching workers assemble B-24 Liberator bombers in conditions that made his teeth clench. Sorensen was Ford Motor Company's production chief. 60 years old, Danish immigrant, hard as railroad iron, he'd been with Henry Ford since 1905, started as a $3 a day pattern maker, rose to become the man who actually built the assembly line that changed the world. If there was anyone alive who understood mass production, it was Charles Sorensen. Next to him stood Ed L. Ford, the company president, 45 years old, Henry Ford's only son. They'd flown from Detroit to see how Consolidated built the bomber the Army Air Corps desperately needed. What Sorensen saw made him want to leave immediately. The bombers were being assembled outdoors in the California sun. Workers attached engines to airframes using makeshift rigs. The heat distorted metal parts out of shape. Nothing was standardized. Each aircraft required constant fitting and refitting because no two parts were exactly alike. Consolidated had received a contract to build these bombers, but after months of work, they'd completed 7 aircraft total, delivered 3. The war in Europe was destroying nations. France was occupied. Britain was being bombed nightly. President Roosevelt had asked American industry to produce 50,000 combat aircraft to confront what he called the approaching storm of global war. That number exceeded every plane built in America since the Wright brothers flew at Kitty Hawk in 1903. Consolidated couldn't even build 8 bombers in 6 months. The Army Air Corps had brought Ford into this project, hoping the automotive giant could manufacture parts and subassemblies, just components, ship them to Consolidated for final assembly. Standard procurement approach. But Sorensen stood there watching grown men struggle to attach wings that didn't quite fit to fuselages that had warped in the sun. And he knew this would never work. The B-24 was complicated. 67 feet long, wingspan of 110 feet for engines, 10 crew members, 5 million individual parts. A Ford automobile had 15,000 parts. This was a 100 times more complex. Every aviation expert in America said you couldn't build aircraft like you built cars. Too many variables, too much precision required. Every plane was essentially custom-made. But Sorensen saw something the aviation experts didn't see. He saw the same fundamental manufacturing problem he'd solved 20 years earlier with automobiles. Move the product, not the workers. Standardize parts, create subassemblies, feed them to a main line at precise intervals. Simple physics, simple logistics, massive output. That night in his hotel room, Sorensen couldn't sleep. His mind raced with calculations, layouts, workflows. He grabbed hotel stationery and a pencil, started sketching. He broke the B-24 into major assemblies. Fuselage, wings, tail section, landing gear, engines, then broke those into subassemblies. Wing sections, engine mounts, control surfaces. 69 subassemblies total, each built on its own line, each feeding into the main assembly at exactly the right moment. He sketched the plant layout, more than a mile long. 2 parallel assembly lines, raw materials entering one end, finished bombers exiting the other. Every hour, 24 hours a day, 7 days a week. At breakfast the next morning, Sorensen showed Edel the sketch, explained the concept. 1 bomber per hour, a preposterous claim. Consolidated took weeks to build 1 aircraft. Sorensen was proposing to build 1 every 60 minutes. Edel looked at the pencil drawing, looked at Sorensen, said Ford Motor Company would build such a plant. They met with Consolidated that afternoon. Sorensen explained his plan. The aviation people listened politely, then said it was impossible. Aircraft weren't automobiles. You couldn't standardize complex bombers the way you standardize simple cars. The tolerances were too tight, the engineering too sophisticated. Mass production worked for Model T Fords. It would never work for 4-engine heavy bombers. Sorensen asked them a direct question. How would you do it? They had no answer. Their outdoor assembly method was all they knew. It was slow. It was inefficient. but it was how aircraft had always been built, one at a time by skilled craftsmen, custom work. Sorensen told them Ford wouldn't just build parts. Ford would build complete aircraft on a moving assembly line at automotive production rates. The Army would get its 50,000 planes, but not the consolidated way, the Ford way. The meeting ended badly. Aviation executives thought Sorensen was arrogant, didn't understand their industry, would fail spectacularly, and waste government money. They filed reports saying so. What they didn't know was that by the time Sorensen returned to Michigan, he'd already committed Ford Motor Company to the largest manufacturing gamble in American history. The cost of slow bomber production was measured in missed opportunities and delayed operations. In 1941 and early 1942, the Army Air Forces faced a critical shortage of heavy bombers. Training squadrons worked with obsolete aircraft because new production couldn't keep pace with demand. Combat units deployed to theaters with fewer aircraft than their table of organization required, limiting their effectiveness. The strategic bombing campaign against Germany, central to American war plans, couldn't begin in earnest until sufficient bombers were available. British forces were conducting night raids with heavy losses. American doctrine called for daylight precision bombing, but that required massive formations for mutual defense. Massive formations required hundreds of aircraft. In all of 1941, American factories built fewer than 2,000 heavy bombers. Germany was producing war materials at full industrial capacity, while America struggled to field enough aircraft to mount effective operations. General Henry Arnold, commanding the Army Air Forces, knew that at current production rates, America wouldn't have sufficient bombers for sustained strategic campaigns until late 1944. The war might be decided by then one way or another. Meanwhile, construction crews were tearing apart Henry Ford's farm. The site Sorensen chose was 1,875 acres of Ford-owned land near Ypsilanti, Michigan. It had been Camp Willow Run, a summer farm camp for boys whose fathers were killed or disabled in World War I. Henry Ford ran it as a character-building operation. Boys lived in tents, woke at 5:30, attended church services before breakfast, worked the fields all day. Ford believed hard work built men. Now, bulldozers were leveling the woodlot. 300 men with saws, axes, and equipment attacked 100 acres where the plant would sit. A steam-powered sawmill from Ford's Greenfield Village Museum converted felled trees to 400,000 board feet of lumber. The fields were cleared for construction. Henry Ford hated the project. He was 77 years old, increasingly unpredictable, fiercely isolationist. He'd opposed American involvement in World War I. Now, another European war was pulling America toward intervention, and Ford wanted no part of it. He'd initially refused government requests to build military equipment, forced Edsel to cancel contracts for aircraft engines for Britain, but Edsel had convinced him this was different. This was defending America, and despite his isolationism, Henry Ford ultimately agreed, partly because Edsel pushed, partly because Charles Sorensen convinced him the engineering challenge was worth solving, mostly because Henry Ford never could resist proving people wrong. And every aviation expert in America said this plant would fail. Architect Albert Kuhn designed the structure. Kuhn had designed the River Rouge complex and hundreds of other manufacturing facilities. He proclaimed that Willow Run would be the most enormous room in the history of man. He might have been right. The main building measured 3,200 feet long, 1,279 feet wide at its widest point. 80 acres of interior space, 20% larger than the Empire State Building's total floor space, one level, no interior support columns, a clear open factory floor, more than a mile long. The layout was L-shaped. Folklore says Henry Ford insisted the eastern perimeter not cross into Wayne County, home to Detroit Democrats and union organizers. Whether true or not, the shape created an engineering problem. The assembly line had to turn 90 degrees near the end. Sorensen solved it by installing two massive turntables to rotate completed fuselages through the turn. Construction began April 18, 1941. 5 main contractors worked simultaneously. The building went up in sections. Workers erected plywood partitions to seal finished portions from areas still under construction. Production equipment was being installed in completed sections while construction continued on unfinished areas. The first sections opened for production in September 1941, 3 months before Pearl Harbor. What came next was 20 months of spectacular failure. The aviation experts had been right about one thing. Building bombers wasn't like building cars. Consolidated Aircraft retained design control. So did the Army Air Corps, for it had no authority to modify anything. Consolidated could call Willow Run anytime and demand changes. They called every day, sometimes multiple times per day. Sorensen had dispatched 70-man teams of Ford engineers to San Diego to learn everything about B-24 construction. They discovered the engineering drawings were useless, incomplete, filled with discrepancies, covered in unfamiliar symbols. Many specifications existed only in the memories of consolidated foremen. Sorensen had 2 Liberators flown to Dearborn, dismantled them piece by piece. His engineers created complete drawings from the actual aircraft. 200 engineers worked around the clock, 7 days a week, producing what became known as 5 miles of drawings daily. They worked in shifts, day crew, night crew, 7 days a week, creating the documentation Consolidated should have provided. 10,000 of the 30,000 drawings they created were obsolete before they reached production. Consolidated kept changing the design. The B-24 was evolving rapidly. In 1941 and early 42, the Army Air Corps was learning what worked in combat and what didn't. They wanted more defensive armament, better turrets, modified bomb bays, improved engines. Each modification made the aircraft better. Each modification disrupted Ford's assembly line. Every change required retooling. Ford's mass production system demanded fixed specifications, standardized parts, identical aircraft, but Consolidated modified the B-24 constantly. The B-24A became the B-24C. The C became the D. The D became the E. New gun positions, different turrets, redesigned tail assemblies. The B-24E, the first model Ford built in quantity, had a power-operated top turret. The earlier models didn't. That meant new tooling for the fuselage opening, new electrical systems, new hydraulic lines. Ford engineers designed the tools, installed them, trained workers, started production, then Consolidated announced changes to the E model. The modification that caused the most disruption came in mid-1942. The Army wanted a nose turret for frontal defense. The B-24 had been designed with a greenhouse nose for the bombardier. No turret. German fighters had learned to attack head-on where American bombers had the least defensive fire. The nose turret was essential. It was also a complete redesign of the aircraft's forward structure. Ford engineers had to redesign jigs, tools, and assembly procedures for the entire forward fuselage. The work took months. While they redesigned, production slowed to a crawl. When the new jigs were ready, workers had to be retrained. The first B-24H models, with nose turrets, didn't leave Willow Run until late June 1943, 10 months behind schedule because of one modification. The first bomber took 10 months to build. It rolled off the line October 1, 1942. Workers christened it the Spirit of Ypsilanti. It was supposed to have been completed in May. Newspapers that had praised the project started calling it Willow Run. Willow Run became a national joke. The massive factory that was supposed to prove American industrial superiority was producing almost nothing. In all of 1942, Willow Run built 56 complete aircraft. Most were actually assembled by Consolidated or Douglas in Oklahoma and Texas from Ford-produced subassemblies. The mile-long assembly line barely functioned. Workers couldn't get to the plant. The facility was 25 miles from Detroit. Wartime rationing, limited gasoline and tires. Public transportation was inadequate. Rural roads connecting Ypsilanti to Detroit were two-lane highways designed for light traffic. Now thousands of workers tried using them simultaneously for shift changes. In 1 month, Ford hired 2,900 workers, lost 3,100 people, took jobs, worked a week, discovered the commute was impossible, quit. The turnover rate was devastating. More workers quit than were hired. The plant was losing workforce faster than recruiting could replace them. Those who stayed found working conditions miserable. The factory had started production before construction finished. Half the building had no heat in winter. Michigan temperatures dropped below zero. Workers wore heavy coats while assembling precision aircraft parts with frozen hands. Condensation from body heat froze on metal surfaces. Tools were so cold they stuck to bare skin. In summer, conditions reversed. The massive factory had no air conditioning. Temperatures inside reached 100 degrees. Workers collapsed from heat exhaustion. The factory floor was metal and concrete. It radiated heat like an oven. Fans moved hot air around but didn't cool anything. Labor turnover exceeded 100% annually. Training took weeks. New workers spent their first month learning basic aircraft assembly. By the time they became proficient, they'd quit. New workers replaced them. Needed training, quit before becoming productive. The cycle repeated endlessly. Experienced workers were training replacements who would never stay long enough to become experienced themselves. Absenteeism ran 20 to 30% daily. Workers called in sick went to work at other Detroit factories with better conditions, better pay, easier commutes. Ford couldn't fire them. Every company in Detroit was desperate for workers. Fire someone at Willow Run, they'd have a new job by afternoon, probably making more money. The housing crisis became critical by late 1942. Workers were sleeping in cars, renting rooms in shifts. 3 men sharing one bed, 1 work days, 1 work nights, 1 worked swing shift. The bed was never empty. Landlords charged double and triple rent. Why rent to one family when you could rent the same space to 3 different shift workers who'd never be there at the same time? The federal government finally stepped in. In February 1943, the first dormitory opened. Willow Run Lodge, 15 buildings containing 1,900 rooms. Some single occupancy, others double. Space for 3,000 people. It wasn't enough. Between June and December 1943, construction crews built temporary buildings for 2,500 families. Willow Run Village, 4, 6, or 8 apartment flat tops, 1, 2, or 3 bedrooms. The West Court buildings had peaked roofs. Some had no bedrooms, called zero-bedroom apartments, essentially large rooms with kitchens and bathrooms. Couples lived there. 3 adults could share one. A trailer park followed. 1,000 mobile homes, community laundry facilities, shared shower and toilet buildings. Workers bought or rented trailers, parked them in rows, lived there for the duration. Some trailers had been summer vacation campers. Now, they were year-round homes for families with children. Another dormitory, West Lodge, added 1,960 rooms in August 1943. By the end of 1943, 6 different temporary housing projects surrounded Willow Run, 2 dormitories, 2 trailer parks, 2 family housing complexes. Together, they sheltered more than 15,000 people, roughly equal to the entire population of Ypsilanti at that time. The government built parkage homes separately in 1943 for African-American workers. Willow, Run, Lodge, and Village were segregated. The Detroit Housing Commission and National Housing Agency refused to integrate them. Noted African-American architect Hillard Robinson designed Parkridge, 80 units, separate but theoretically equal. In practice, fewer units for black workers than white workers despite similar workforce percentages. Then Senator Harry Truman came to investigate. Truman headed the Senate Special Committee to investigate the National Defense Program. His job was eliminating waste in military contracts. Willow Run's problems had reached Washington. Truman arrived in April 1942 to see if the government should nationalize Ford Motor Company and take over the plant. Ed L. Ford met him personally, explained the design change problem, showed him documentation. Every day, sometimes multiple times daily, Consolidated called with modifications. Each change cascaded through the production system, causing delays, requiring expensive retooling. Truman wasn't interested in excuses. He wanted finished bombers. The investigation continued into February 1943. Truman toured the facility again, saw the massive empty building, the barely moving assembly line, the handful of aircraft being built, but his committee's final report cleared Ford. The delays weren't the company's fault. Consolidated's constant meddling was preventing production. The committee gave Willow Run a clean bill of health, then recommended that one person be given complete authority over the program. No more design changes, no more interference from Consolidated. One manager, total control. Production began climbing slowly at first, then with increasing momentum. 37 complete aircraft in January 1943, 70 in February, 96 in March, 146 in April. The numbers told the story. Willow Run was finally working. The transformation wasn't magic. It was systematic problem solving. Every bottleneck identified and fixed. Every delay analyzed and eliminated. Every inefficiency improved. The Truman Committee's investigation had forced changes. One manager, Bicker, was given authority over the entire program. No more divided responsibility. No more conflicting orders. One person made decisions. Everyone else followed them. Consolidated design changes slowed, then stopped. The Army Air Forces standardized on the B-24J model in spring 1944. Final design. No more modifications. Build this version and only this version. That standardization was what Ford needed. Fixed design meant tooling. Could be perfected instead of constantly changed. The workforce stabilized. Housing projects meant workers could actually live near the plant. Commute times dropped. Absenteeism dropped. People stayed in jobs long enough to become skilled. Skilled workers trained new workers more efficiently. The training cycle stopped being a treadmill. The production line itself evolved. Ford engineers made hundreds of small improvements. Better tool placement, more efficient part delivery, improved lighting, better work platforms. Each change saved seconds. Multiply those seconds by thousands of workers doing millions of tasks, and the time savings became massive. By autumn 1943, the plant was producing at rates that seemed impossible 18 months earlier. The 1,000th bomber celebrated November 3rd represented a turning point. From joke to miracle in less than a year, but that success came at a price. Ed L. Ford never saw the plant reach its full potential. His health had been deteriorating for months. The stomach pain he'd been ignoring wouldn't stop. In January 1942, surgeons operated, found metastatic cancer inoperable. They closed him up and told him he had months, maybe a year. Edel worked anyway, through pain, through the knowledge he was dying, through radiation treatments that made him sick. He'd made a promise, 1 bomber per hour. He was going to see that promise kept. He attended meetings when he could barely walk, reviewed production reports from a hospital bed, made decisions about tooling modifications while recovering from treatments. His staff begged him to rest. He refused. Willow Run needed him. The stress undoubtedly accelerated the cancer's progression. Medical historians agree on this. The constant pressure, the battles with Consolidated, the fights with his father, the government scrutiny, the media criticism, all of it wore him down. The cancer was killing him anyway. The stress made it kill him faster. Henry Ford didn't understand. Thought Edel just needed rest. Thought a chiropractor could cure him. Couldn't accept that his only son was dying of a disease that medicine couldn't stop. Henry's denial made things worse. Added guilt to Edel's burden. His father thought he wasn't trying hard enough to get better. Ellen Ford, Edsel's wife, watched him deteriorate, watched the pain increase, watched the treatments fail, watched her husband sacrifice himself for a factory. She later said the project killed him. The cancer was there, but Willow Run accelerated everything. Edel Ford died at home in Grosse Pointe Shores at 1:10 in the morning on May 26, 1943, age 49. The stress of Willow Run had consumed the last 18 months of his life. His funeral was May 28th. Thousands attended, business leaders, government officials, Ford employees. The entire Willow Run workforce shut down for the day. Workers lined up outside the church. too many to fit inside. Henry Ford was devastated, lost without his son. 6 days after the funeral, he announced he was reassuming the presidency of Ford Motor Company. The board was horrified. Henry was 79 years old, clearly in mental decline, physically weak. He sometimes didn't recognize his own executives, but he owned the majority of the stock. Nobody could stop him. The government panicked. Ford Motor Company was building bombers, jeeps, tank engines, aircraft engines. Critical war production depended on Ford. The company couldn't be run by someone who might not remember what year it was. Secretary of War Henry Stimson spoke with Elenina Ford, explained the situation. The country needed Ford Motor Company functional. Someone competent had to run it. Elenina agreed. She and Clara Ford, Henry's wife, together convinced Henry to step aside. Edsel's son, Henry Ford II, was pulled from Navy service, came home, took over the company September 21, 1945, 28 years old. No business experience. Suddenly running one of America's largest corporations during wartime. Young Henry had to learn fast. The company was chaotic. His grandfather had let things deteriorate. Management was a mess. Only the production side, run by Sorensen and his team, functioned well. The rest of the company needed complete reorganization. Young Henry watched Willow Run hit its peak production rates in spring and summer 1944. Watched his father's promise finally kept. One bomber every 63 minutes. Edsel never lived to see it, but his son did. Young Henry made sure everyone knew this was Edsel's achievement, not Henry Sr.'s, not Sorensen's alone. Edsel's. The price had been Edsel's life. But the achievement was real. Willow Run worked. The promise was kept. The center wing was the structural heart of the aircraft. It connected the two outer wing panels, housed the main landing gear, contained the bomb bay, and supported all 4 engines. Everything attached to the center wing. Get it wrong and nothing else would fit correctly. Consolidated built each center wing using a temporary wooden jig. The jig was a precisely shaped framework that held the wing ribs, spars, and skin panels in correct alignment while workers riveted them together. Build the wing inside the jig. Rivet everything, remove the finished wing, throw away the jig, build a new jig for the next wing. Each jig took 250 man-hour to construct. Skilled carpenters built them from templates. Every measurement had to be perfect. Any error in the jig meant errors in the wing, and errors in the wing meant the aircraft wouldn't fly correctly. The jigs were single-use. After one wing, they were scrap lumber. Ford engineers looked at this process and saw waste. 250 hours of skilled labor producing something used once and discarded. That wasn't mass production. That was custom craftsmanship. They designed a permanent steel jig, heavy framework made from precision machined steel members. The jig could handle multiple wings without warping or wearing. Move wing structure in with an overhead crane. Complete all assembly work while the structure sat in the jig. Remove finished wing with crane. Insert next wing structure. Repeat. The permanent jig took weeks to design and build. It costs significantly more than wooden jigs, but it could be used indefinitely. More importantly, it was precisely machined. Every wing built in that jig would be identical to every other wing. Perfect standardization. The first permanent jig reduced center wing assembly time from 250 man-hours to 1 man-hour. One person could install wing ribs into the jig in the time it previously took 250 carpenters to build a throwaway jig. Ford built multiple permanent jigs, positioned them along the assembly line. Wings moved from station to station. Each station added specific components. Ribs at Station 1, front spar at Station 2, rear spar at Station 3, skin panels at Station 4, fuel tanks at Station 5, landing gear attachments at Station 6, inspection at Station 7. The process became so efficient that by late 1943, center wing assembly was the fastest section of the entire production line. What had been the biggest bottleneck became the pace setter. The permanent jig innovation spread to other assemblies. Fuselage jigs, tail section jigs, engine nacelle jigs. Every major component got permanent tooling instead of throwaway jigs. The time savings compounded across the entire assembly process. On November 3, 1943, workers celebrated the 1,000th finished B-24. One person who should have been there wasn't. Edsel Ford had died 6 months earlier. By autumn 1943, leadership at Willow Run passed from Charles Sorensen to me Bricker. The government requested Ford decentralized operations. Many subassemblies moved to other Ford plants and subcontractors. Willow Run concentrated on final assembly. The bugs were worked out. The design changes stopped. The workforce stabilized. Housing was built near the plant. Dormitories for single workers. Apartments for families. Willow Run Village, 15,000 people larger than the city of Ypsilanti. Women flooded into the factory as men were drafted. By May 1942, 15% of the Willow Run workforce was women. That percentage climbed steadily. By summer 1944, thousands of women worked at Willow Run. They filled every role except the heaviest physical labor. Women worked as riveters, the most critical skilled position in aircraft assembly. Riveting required precision. Drive the rivet too hard, you crack the aluminum skin. Too soft, the rivet doesn't hold. Perfect pressure, perfect angle thousands of times per shift. Women became experts. They worked as welders. Spot welding, arc welding, gas welding. Joining aluminum parts required different techniques than welding steel. Aluminum melts at lower temperatures, conducts heat faster, warps easily. Women learned the skills, passed the qualification tests, worked alongside men doing identical jobs. They worked as mechanics, installing engines, mounting propellers, connecting control cables, hydraulic systems, electrical systems, fuel systems. Every system in a B-24 had to be installed, tested, adjusted, and inspected. Women did all of it. They worked as inspectors. Quality control was critical. Every rivet had to be checked. Every weld had to be tested. Every system had to function perfectly. An aircraft with faulty rivets would come apart in flight. Women inspectors caught defects before aircraft left the factory. They earned the same wages as men for the same jobs. Ford had mandated equal pay. A woman riveter made the same hourly rate as a male riveter. A woman mechanic made the same as a male mechanic. This wasn't universal in wartime industry. Many factories paid women less than men for identical work. Ford didn't. Rose Willow Monroe became one of the most famous Willow Run workers. She worked as a riveter on the night shift, drove rivets into B-24 fuselages. In 1944, actor Walter Pidgeon toured Willow Run for a promotional film. He saw Monroe working. She fit the image the War Production Board wanted for recruitment posters. Young woman, attractive, clearly competent, doing traditionally male work. Monroe appeared in promotional materials for war bonds. Some sources claim she inspired the Rosie the Riveter character, though this is disputed. Multiple women named Rose worked in war industries. Several appeared in promotional materials. The iconic Rosie image was already established before Monroe's publicity. Whether she inspired the character or simply fit an existing image remains unclear. What's certain is that thousands of women worked at Willow Run. They learned skills most had never imagined learning. They earned wages most had never earned before. They built bombers that flew in combat. Knowing their work directly supported the war effort. Many had husbands, brothers, sons in uniform. Some were flying the same aircraft these women built. That knowledge drove quality. Every rivet mattered. Every weld mattered. Bad work meant someone's son might die. Good work meant someone's son might survive. After the war ended, most women workers were laid off. The men came home from service, took back the jobs. The social expectation was that women would return to domestic life. Many did, but thousands had learned they could do work they'd been told was impossible for women. That knowledge didn't disappear. The skills didn't disappear. The women who worked at Willow Run became nurses, teachers, business owners, factory supervisors. They'd proven to themselves what they could do. That proof changed lives, changed families, changed expectations for their daughters. The production rate climbed steadily, then explosively. In 1944, Ford was rolling a Liberator off the Willow Run production line every 63 minutes, 24 hours a day, 7 days a week. Peak monthly production came in April 1944. 453 complete bombers, more than Consolidated, had built in all of 1941. Between April 24th and April 26th, 100 completed bombers flew away from Willow Run. 33 aircraft in 48 hours. The transformation from joke to miracle had taken less than a year. What neither Sorensen nor anyone else at Ford fully understood was how this terrified Germany. German forces experienced the results firsthand. Every week, dozens of new American bombers arrived in England. Every month, hundreds. Losses that should have crippled American bombing capability for weeks were replaced in days. The Luftwaffe faced growing formations of well-equipped aircraft. Formations of 500 bombers became routine. Then 700, then 1,000, all equipped, all supplied, all replaced within days of being shot down. By 1944, American production records showed Willow Run alone was producing aircraft at rates that rivaled entire national industries. The plant's output of finished airframes approached the total production of some Axis powers. German fighter pilots, who'd felt confident in 1943, grew increasingly desperate in 1944. They were destroying bombers, but every bomber shot down was replaced by 2 more. Every pilot killed was replaced by 3 more. The Luftwaffe tried new tactics, better fighters, rocket weapons. None of it changed the fundamental mathematics. American factories were producing faster than German fighters could destroy. By late 1944, the air war over Germany had shifted decisively. The endless stream of replacement aircraft, crews, and equipment overwhelmed German defenses through sheer industrial capacity. Charles Sorensen never saw final victory. He retired from Ford Motor Company on March 13, 1944, as he'd planned with Henry Ford since 1941. His retirement came just as Willow Run achieved its peak production. He'd spent his entire adult life at Ford. 39 years, started as a $3 a day pattern maker, rose to become the vice president of production, built the assembly line that changed manufacturing, designed the Willow Run plant that proved aircraft could be mass-produced like automobiles. After leaving Ford, Sorensen became president of Willys Overland Motors, led the company's transition from wartime Jeep production to civilian automobile production, developed the Jeepster, a sporty civilian vehicle derived from the military Jeep. He clashed with Willys board members over company direction, retained a title and salary as vice chairman from 1946 until fully retiring in 1950, then moved to Florida and the U.S. Virgin Islands. Sorensen had extensive land holdings in Cuba seized by the new government after the Cuban Revolution. He died on August 11, 1968 at Bethesda Naval Hospital in Maryland. Age 86, buried in Miami Beach, Florida. He'd outlived both Henry and Ed L. Ford. His obituary mentioned his role at Ford Motor Company, mentioned the assembly line, mentioned Willow Run, but most people remembered him as Ford's production chief. Few understood he'd fundamentally changed how wars could be fought, not through brilliant tactics, through overwhelming industrial production. Mee Bricker, who took over Willow Run leadership after Sorensen, stayed until production ended. The last B-24 left Willow Run on June 28, 1945, named the Henry Ford. It flew away 3 months after Germany surrendered, weeks before Japan capitulated. Total production 6,792 complete aircraft built and flown from Willow Run, plus 1,893 knockdown kits shipped to Douglas Aircraft in Tulsa and Consolidated in Fort Worth for final assembly. Combined total of 8,685 B-24 Liberators produced through Willow Run. More than half of all B-24s ever built came from one plant in Michigan. Those aircraft flew in every theater: Europe, Pacific North Africa, China, Burma, India. Anti-submarine patrols over the Atlantic, strategic bombing over Germany, island-hopping campaigns across the Pacific, long-range reconnaissance. The B-24 served in more roles and more locations than any other American bomber. The B-24 had greater range than the B-17 Flying Fortress. It could fly farther, carry more bombs, reach targets the B-7 couldn't reach. That range made it essential for Pacific operations where targets were separated by thousands of miles of ocean. In Europe, B-24s flew from bases in England and Italy. The 15th Air Force in Italy operated primarily B-24s. They bombed oil refineries in Romania, aircraft factories in Austria, rail yards in southern Germany. While the 8th Air Force in England flew B-17S and B-24s against targets in northern Germany and occupied France, the most famous B-24 raid was Operation Tidal Wave on August 1, 1943. 177 B-24s attacked oil refineries at Pești, Romania. The refineries supplied one-third of Germany's fuel oil. Destroying them with German military operations. The raid was a tactical disaster. 53 B-24s were lost. 660 airmen were killed, captured, or interned. 5 men earned the Medal of Honor. The refineries were back to full production within weeks. But the raid demonstrated what B-24s could do. They'd flown nearly 2,000 miles round trip to strike the most heavily defended target in Europe. In the Pacific, B-24s closed the Atlantic Gap. That was the mid-Atlantic region where German U-boat operated without fear of air attack. Aircraft based in Iceland or Britain couldn't reach that far. Aircraft based in America couldn't reach that far. The gap was beyond everyone's range. Very long-range Liberators changed that. B-24S stripped of some armor and gun turrets to save weight. Extra fuel tanks installed in the bomb bay. They could fly farther than any other aircraft in 1942 and early 43. They patrolled the Atlantic Gap, found surfaced, attacked them with bombs and depth charges. U-boat crews called them the terror of the Atlantic. A U-boat could submerge in 60 seconds. But if a Liberator caught them on the surface, 60 seconds wasn't enough. The Liberators carried radar. They could find U-boat at night, find them in bad weather, find them when lookouts couldn't see them coming. The Atlantic Gap closed in mid-1943. Allied shipping losses dropped dramatically. The U-boat threat never disappeared, but it was contained. Very long-range Liberators made that possible. The 8th Air Force units that flew B-24s included the 44th Bomb Group, the Flying 8-Balls. They arrived in England in November 1942, flew 343 combat missions by war's end, dropped 18,980 tons of bombs, lost 192 aircraft, claimed 3 to 30 Luftwaffe fighters destroyed. The 93rd Bomb Group, the traveling circus, flew B-24s from England and North Africa. First B-24 Group to bomb Germany. First to bomb Pești, first to fly missions from North Africa against Italian targets. The 15th Air Force's 49th Bomb Group operated from Italy. They bombed targets throughout southern Europe and the Balkans, oil refineries, aircraft factories, transportation hubs. By war's end, they'd flown 396 combat missions. Every one of these groups flew Willow Run B-24S. Every month, new aircraft arrived from Michigan, replacements for losses, expansion for new squadrons. The steady stream of aircraft kept combat units at full strength despite heavy casualties. The impact on the war was immeasurable, not just from the bombers themselves, but from proving mass production worked for complex weapons. After Willow Run, the Pentagon knew America could build anything at automotive production rates. Tanks, trucks, aircraft, ships. The limiting factor wasn't capacity. It was design. That confidence changed American military strategy for the next 75 years. America would win wars through industrial overwhelming force, not through superior tactics or technology, though those helped. Through building more weapons than enemies could destroy. Through replacing losses faster than enemies could inflict them. Willow Run proved it could be done. The plant itself changed hands after the war. Kaiser Frazer bought it for automobile production, later sold to General Motors. Parts were demolished, parts were repurposed. The iconic final assembly bay, with its massive doors where completed bombers rolled out to the adjacent runway, was preserved. In 2013, a campaign to save part of the original bomber plant succeeded. The Yankee Air Museum acquired approximately 175,000 square feet, less than 5% of the original factory. It includes the end of the B-24 assembly line and the two famous bay doors where finished bombers left the plant during World War II. Today, you can visit stand where workers assembled bombers at a rate aviation experts said was impossible. See the space where Charles Sorensen's sketch became the physical embodiment of American industrial might. But perhaps the most important legacy isn't the building. It's the lesson. That's how mass production defeats conventional wisdom. Not through small improvements or clever tactics. Through fundamentally reimagining what's possible through taking methods everyone says won't work and proving them wrong at scale. Charles Sorensen sketched Willow Run on hotel stationery in one night because he saw past what aviation experts knew. They knew aircraft had always been built slowly by craftsmen one at a time. Sorensen knew that anything built by humans could be standardized, systematized, and mass-produced. The aviation experts said no. Too complex, too many variables, too much precision required. Sorensen built it anyway, broke every aviation industry convention, created new methods, solved problems nobody thought were solvable. And when it worked, when one bomber every 63 minutes became reality, it changed how America fights wars. Not through superior soldiers, through superior production. Ed L. Ford didn't live to see peak production. But he saw enough. He saw the plant work, saw the production rate climb, saw his promise to America kept. He died knowing Willow Run would succeed. The cost was his life. The stress, the pressure, the endless battles with Consolidated, with the government, with his own father. Medical historians believe the cancer was present before Willow Run, but stress accelerated it. The project consumed 18 months of his life, killed him at 49. His family never forgot. His son, Henry Ford II, who took over the company in 1945, told the story of Willow Run to every young engineer who joined Ford, made sure they understood that sometimes the most important achievements require impossible commitment. That changing industries means fighting everyone who says it can't be done. That being right doesn't make the battle easier. For the workers who built those bombers, Willow Run meant jobs, paychecks, and purpose. Many had sons or husbands in uniform. Building bombers felt like protecting them. For bomber crews, each aircraft from Willow Run meant survival, replacements for losses, reinforcements for understrength squadrons. The sustained pressure that eventually wore down German defenses. And for Charles Sorensen, Willow Run was vindication. The automotive production man aviation experts said didn't understand their industry built a factory that changed how America fights wars. Mass production proved it worked for anything humans could design. One factory, 1 mile-long assembly line, more than 8,000 bombers in 3 years. One every 63 minutes at peak production. Built by workers using methods the aviation industry said wouldn't work. Producing results experts said were impossible. That's how innovation actually happens in war. Not through committees or conventional wisdom. Through people who see problems, find solutions, and refuse to accept that something can't be done. If you found this story as compelling as we did, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters. Each one deserves to be remembered. And we'd love to hear from you. Leave a comment below telling us where you're watching from. Our community spans from Texas to Tasmania, from veterans to history enthusiasts. You're part of something special here. Thank you for watching, and thank you for keeping these stories